Hi my dear friends, my name is Abhishek and you are watching Maths Magic channel on YouTube. Today we are going to discuss, learn and solve exercise 1.2 completely. For that you need to have a scale, 180-degree circle master, scale, compass and eraser, so that you can solve this exercise completely. Moving on to the question number 1. State whether the following statements are true or false. Justify your answers. Statement number 1 is every irrational number is a real number. Every irrational number is a real number. We know that irrational number cannot be written in the form of p by q, and real number comprises of rational number and irrational number. So first statement is true because every irrational number will be real number. That we have already studied in the topic number 1.2 earlier, that real number is a mixture of rational number and irrational number. So every irrational number will be real number. So statement 1, that every irrational number is a real number, is true because real number are combination of rational number and irrational number. Then second statement, every point on the number line is of the form root m, where m is a natural number. Here they are telling that every point on the number line is of the form root m. Every point on the number line. They are discussing for every point on the number line. Here points on the number line are also negative, not only positive. If they are telling about the natural number are always positive only. No negative numbers will come in the natural number. Suppose we are taking here they have told you to take root m as natural number. So we take root m as, we take the value of m as 4, 9 and 16. Then we will get root m as, for m is equal to 4, we will get 2 as the answer. I have denoted 2 with red, 3 with red and 4 with red. And 9, if we keep 9 in place of m, we will get 3. If we keep 16 in place of m, we will get 4. Generally we know that root 4 is equal to plus or minus 2, root 9 is equal to plus or minus 3. But in this chapter first, number system, we know that in the topic number 1.2 we have already discussed that when we use the symbol root, we assume that it is the positive square root of the number. It will always be positive. There are no negative numbers, and they have given detail that root 4 is equal to 2, though both 2 and minus 2 are square roots of 4. We will consider only positive. That's why here answer is false. Answer is false. No negative number can be square root of any natural number, because negative numbers are also positive present on the number line. So here answer is false for this chapter number 1. Statement number 3, every real number is a rational number. This is the statement number 3. Every real number is an irrational number. This is false because we have seen that real number are a combination of rational number and irrational number. We have seen in topic number 1.2 already that real number are the combination of rational number and irrational number. So it is not only irrational number, there are possibility of rational numbers also in the real numbers. So this statement number 3 is false because real number are also consist of rational numbers, general form p by q, and which are not irrational number. Here rational numbers are also present whose general form is p by q, which are not irrational number. Thus the statement 3, that every real number is an irrational number, is false. Question number 2 is given, are the square roots of all positive integers irrational? They have told you that if you do the square root of positive integers, they are all irrational. If not, give an example of the square root of a number that is rational number. They are telling you to give the example of rational number for positive integers. Suppose we take the positive integer 1, 2, 3, 4, 5, 6, 7, 8, 9 up to infinite. I have written up to 16, then infinite. I have done 3 dots, which means that we can go up to infinite. So they are telling that if we make the square root of all these positive integers, they are all irrational. No, it is not, because if you take the root of 4, the answer is 2. You can write 2 as 2 by 1. This is the form of p by q, where q is not equal to 0. That is the condition of rational number. If you take 9, that is root 9 is equal to 3. You can write 3 is equal to 3 by 1. This is also form of p by q, where q is not equal to 0. If you take 16, then see root 16 is equal to 4. You can write 4 upon 1. 1 is always present. For 25 it is 5. 5 upon 1 you can write, this is the form of p by q, q not equal to 0. For root 36, answer is 6. You can write 6 upon 1. For root 49 you can write 7. That is 7 upon 1. For root 64 you can write 8. And answer is 8 upon 1, where q is not equal to 0. For root 81, answer is 9. You can write 9 upon 1. For root 100 you can write 10. Answer is 10 upon 1, where it is of the form p by q, where q is not equal to 0. So there are lots of numbers which are not irrational. These are all rational numbers in the positive integers. So the answer is no, square roots of all positive integers are not irrational. Now moving on to the question number 3. Show that root 5 can be represented on the number line. Two methods are there. One method is shown in our book, that is square root spiral method. Another method is Pythagoras theorem method. That is a shortcut, but we will go first with the square root spiral method. First of all, we will draw the number line. Then we will take the distance of 1 centimeter here. We have taken the distance of 1 centimeter here. Then we will denote this point as A. So this is 1 unit. Now we will take the 90-degree angle. 90-degree angle, and we will draw a line. Now we will take the distance of 1 unit here, and we will name this point as B. Now draw the line OB. So OB is root 2. Now again OB, from the OB line draw a perpendicular, means 90 degree, and take the distance of 1 unit. You will get point C. Now join OC. Now OC is the base, and drawing CD as the perpendicular to the OC, we get a line CD. Now take a distance of 1 unit. You get point D. Now from OD as the base, draw a perpendicular line. Now we will get point E at a 1 unit. This 1 unit, this D is the 1 unit. CD is also 1 unit. BC is also 1 unit. AB is also 1 unit. So OB is root 2, OC is root 3, OD is root 4, OE is root 5. Now what you have to do? You have to take the compass and take the measurement of OE and draw an arc directly on the number line. If you draw the arc on the number line, it will touch here after point 2 on the number line. So this distance is called as the root 5. This is your answer. Second method is draw a number line. We know by Pythagoras theorem that root 5 is the addition of 2 square plus 1 square, that is 2 unit plus 1 unit, that is OA square plus AB square, that is 2 square plus 1 square, that is 4 plus 1 5. So in this case you have to take the perpendicular distance of A1. First of all, you have to draw perpendicular from the point 2. Now if after drawing this perpendicular line, you have to take the distance of 1 unit. Now name this point as B. After you name the point as B, join OB. This is root 5. Now take the distance. We have already taken the distance of OE from square root spiral method. The same distance will come here as the answer. Same distance. Now draw the arc on the number line. You get the point P, which is root 5. So this both the method is possible for the given question. Now last, square root spiral. This is classroom activity. All the students have to take the large sheet of paper and draw the square root spiral. For this, I have already done the square root spiral for all of you, my dear friends. Same method which we have done in the question number 3. Same method is done here. Nothing different. But what they have told you, lots of steps are given in your book. I will explain to you in shortly. Explain to you in short terms. So first of all, they have taken the point O and number line is there. 0 to 1 is 1 unit. Then you have to draw perpendicular 90 degree. This is the sign of 90 degree. And take the distance of 1 unit. At 1 unit distance, you will get point P1. Now join OP1. You are getting root 2. Now OP1 as the base and P1 P2 as the perpendicular. You are doing P1 P2 perpendicular to OP1. So you are getting a second point, that is P2. Now join OP2. This is root 3 or the distance of root 3. If you take the compass and take the measurement of OP2 and draw the arc, you will get the root 3 on the number line. Now OP2 as the base and P2 P3 as the perpendicular. OP3 as the base and P3 P4 as the perpendicular. You will get this line. For a OP2 as the base and P2 P3 as the line, you will get root 4. OP3 as the base and P3 P4 as the perpendicular or 1 unit distance, you will get root 5. Same way you can make the square root spiral for up to root 17. You can go further also, but it will be very difficult because you can see lots of lines are getting emerging from the square root spiral. So it will be difficult after root 17. You can draw, but the sheet of paper should be very large and it should be distinct also. Generally, in all the classes and the students of all the standards are doing spiral up to root 17. So I have also done up to spiral of root 17. So thank you and have a nice day, my dear friends. Read all the statements which I have already written here. It is also given in your book also, my dear friends. So read all the statement, solve all the questions 3 to 4 times so that you can have a better grip on each and every question. Thank you and have a nice day.